In this video, we'll look at the derivatives of the trig functions. So uh, there are 6 trig functions, and we want to write down what the derivatives of all of them are. Now, for the purposes of this video, I'm just going to list what the answers are, and then at the beginning of class, we'll talk about why some of these are what they are, and then do some practice with it. So the basic 6 are this. If you have we want to write down derivative of sine, the derivative of cosine, the derivative of tangent, the derivative of secant, the derivative of cotangent, and the derivative of cosecant. Okay, so these 6 are what we're interested in. So, as we'll see, the derivative of sine of x is cosine x. And the derivative of cosine x is negative sine of x. So the negative is sort of sometimes appears and other times doesn't. The derivative of tangent is secant squared x. Derivative of secant is secant x tangent x. Derivative of cotangent is negative cosecant squared x, and the derivative of cosecant is negative cosecant x cotangent x. So there's the 6 of them right there. What this now means is that you know how to take the derivative of every single function under the sun. That is what we call elementary. So that includes the logarithms, polynomials, rational functions, and now that we've got the trig functions, we've got the whole list. So if all we were interested in is just knowing these 6 things, then life would be rather boring. But what we want to do is mix all of this with the derivative rules that we knew from before. So for example, let's say that you have a function f of t is t squared sine t. And let's say I want to find the derivative of this. Well, I know what the derivative of sine is, and I know what the derivative of t squared is, but these two things are multiplied, so I need to use the product rule. So the derivative will be the first thing times the derivative of the second plus the second thing times the derivative of the first thing. And now each of these we know. So this one's t squared cos t plus sine t times 2t. And if you want, you could factor out a t here, but that doesn't really make a difference. Okay, and that's it. So, point being, all of the old derivative rules are still in effect. It's just we've got a new basic piece in here. And you should think about that the same way that you did when we learned what the derivative of e to the x and log of x were. We just mixed those in with all the same old functions that we have done before. Okay, so let's take one more. Let's say, for example, you have g of x equals, let's just spice it up a little bit. Let's take secant of x plus x squared over tangent of x minus sine of x. So here I have a quotient of 2 functions, and so to take the derivative I need the quotient rule. And so I'm going to have a giant fraction, and the bottom is going to be, the whole thing, tan x minus sine x squared. Alright, so what's the derivative of secant? It's secant x, or sorry, we need to do the quotient rule, so wrong order. So let's do the bottom thing. So that'd be tan x minus sine x times the derivative of the top, and this is where we'll need the secant. The derivative of secant is secant x tangent x. Derivative of x squared is 2x minus the top, I'm going to run out of space, times the derivative of the bottom. So since I'm out of space, I'll just put a star. And star is the derivative of the bottom, which is secant squared x minus cosine x. Okay, so again, these 6 basic rules combined with the product rule, the chain rule, the quotient rule, all the other basic derivative rules that we've done in the past mean that we can now take the derivative of any elementary function. And in class, we'll talk about why these 6 things are true, and then we'll do some boot camp style stuff with some more complicated examples.